I want to talk briefly about horizontal asymptotes and just kind of make sure that we have a really clear picture of, first and foremost, what that means, why we look for it, and then kind of how, to quickly sort of figure that out. So it is important to remember that the horizontal asymptote, if I'm taking a look at a graph, the horizontal asymptote is the limit. It's what is happening, it's the limit for what's happening as the x value moves further and further to the right or further and further to the left. So it's something that our function will become infinitely close to, okay? It will get as close as you'd ever want it to, but will never touch as x gets really, really big, or to positive infinity, or all the way to negative infinity. And the reason we want to know this is so that that way we don't have to plot a bunch of points out here, right? We can just say, hey, I know as I move further and further left or further and further right that this is what my graph is, my function is approaching. So to define it formally, the horizontal asymptote of a function f of x is this. So if I have some function f of x, the horizontal asymptote is what my function f of x approaches as x approaches positive or negative infinity. Okay? So what that means is as x is getting closer to positive infinity or negative infinity, what does my function f of x get closer and closer to? What does it approach? And there are three possible scenarios. So the first scenario, remember I'm dealing with rational functions here, so I have a numerator and a denominator. Now the first possibility is that the numerator has a smaller degree than the denominator. So let's just say we have 2x divided by x squared. We'll make these simple, but these apply in all situations here. What is the horizontal asymptote? And what I'm going to do for every one of these functions is we're going to simplify using division. Okay, we're going to see that sometimes that's not necessary, but we're going to talk about what will happen if we simplify with division and how that will always allow us to kind of more clearly see what's happening. So if I were to divide this, and I encourage you to do this off to the side, what will you get? Well, you will get 0. X squared goes into 2x 0 times. 0 plus 2x over x squared. Notice it's exactly the same thing. Okay? And that works just fine. And we could even simplify this further, because think about what this is saying. Right? This is saying that I have 0 plus 2x over x times x. And you know that if I'm multiplying by an x on the top and I'm multiplying by an x on the bottom, those will cancel. Okay, so if I really wanted to simplify this all the way out, I have 0 plus 2 over x. And now this can be a little easier for us to think about. What happens to this function as x approaches positive or negative infinity? Well, think about it. As x gets bigger and bigger and bigger, what's this function getting closer and closer and closer to? And you can try some values. Well, I have 0 plus 2 over some increasingly big number. So what's happening to 2 over some increasingly big number? What happens when you divide 2 by a really, really big number? It gets closer and closer to 0. So as x approaches infinity, my function, 0 plus 2 over x, gets closer and closer to 0. And the reason that we rarely have to do this division is because any time the degree of the denominator is greater than the degree of the numerator, guess what? The denominator is going to dominate It's going to get much, much bigger than the numerator. And so as x gets bigger and bigger and bigger, this function is just going to approach 0. Okay, so that's the first possibility. The second possibility is that the degree of the numerator and degree of the denominator are the same. So let's say we have 3x squared divided by x squared. What's the horizontal asymptote of this function? In other words, what happens as x approaches infinity or negative infinity? And once again, we're going to simplify using division. And if you do that, you're going to get 3. Just exactly 3, right? Notice that x squared multiplied on top and then divided by x squared will cancel, and it makes sense that you're just going to end up with 3 if you do the long division. All right? And maybe it'd make more sense, it would be more helpful to see, what if we had it 3x plus 1? And so here, if I did the long division, I'd have 3 plus 1 over x squared. So here, I want to think about what's happening to this function as x approaches infinity. Well, this should be easy for us to see. So 3 plus 1 over x squared. What happens as x gets bigger and bigger and bigger? Well, this 3 will always be 3, right? There's nothing that's going to change there. But as x approaches infinity, 1 over x squared, 1 over something really, really large squared, is going to get closer and closer to 0. So as x approaches infinity, this function is just going to get closer and closer to 3. And so the horizontal asymptote would be y equals 3. It's important. In the first example, the horizontal asymptote would be y equals 0, the x-axis. And here, the horizontal asymptote would be y equals 3. Okay, so here we can see, again, we're noticing a little bit of a pattern here. When I do the long division, the horizontal asymptote is just going to be whatever the quotient is. The remainder, whatever that remainder piece is always going to approach 0, because I'm going to have some degree that is less than the numerator. The degree will be less than the degree of the denominator. So that remainder portion is always going to go to 0, and I'm noticing that my quotient here, this value 3, or in this example the value 0, is going to be the horizontal asymptote. And now there's one more possibility. There's a possibility where the numerator has a greater degree than the denominator. So let's try this. We have 3x squared, let's go with plus 1 again, and divide it by x. And so what will happen as x approaches infinity? So the first thing we're going to do is we're going to do the long division here. And this is pretty simple. We are going to get 3x plus 1 over x. And what will happen as x approaches positive or negative infinity? Well, think about it. Let's write it out again. What's going to happen to our function? Well, is anything special going to happen to 3 times x? I mean, x is just getting bigger and bigger, but it's still going to be multiplied by 3. There's nothing really strange happening there. But here, 1 over x is going to be getting closer and closer to something, right? This denominator is getting bigger and bigger. 1 over something that's getting bigger and bigger, that's getting closer to 0. So our function will be approaching 3x. So our horizontal asymptote is y equals 3x here, because as you notice, our function, this kind of funky looking thing, which I've simplified here, as x is approaching infinity, I'm really just worried about this 3x, because 1 over some huge number is going to get closer and closer to 0. So for example, to graph this asymptote, it would look like this, and what that means is that, let's say our function is, it's let's say we're just kind of moving like this, and as x approaches infinity, it's getting very, very close to 3x. notice that the function would just be getting closer and closer to that line 3x. So to sum this up, the horizontal asymptote, which is just the value of my function, what my function is approaching as x approaches positive or negative infinity, can be found sometimes much more helpfully by doing the long division. And we know that whenever we do the long division, whatever the quotient is, that ends up being our horizontal asymptote, because every time the remainder portion is going to approach 0 as x approaches infinity. So we don't want to forget y, but we want to note that every time we have the degree in the numerator less than the degree in the denominator, right, that is going to make that piece go to 0 as x gets bigger and bigger and bigger.